Hi everybody, let's do IXL 7th grade A11. I'm in the wrong spot here. Here we go. So go to Learning, then go down to 7th grade, and then go down to A11, Classify Numbers. Okay, so this is a topic that I do not have on the reference pages, which is why I wrote this over here. So let's discuss this for a moment. So we're going to have to know about natural numbers, whole numbers, integers, rational numbers, and irrational numbers. And when I say we have to know something about them, really I just mean we have to know what they are. So what are they? Natural numbers are very simple. You just start with 1, and then to get the rest of them, you just keep adding 1. So 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. 11, 12, and on and on and on. Okay, those are the natural numbers. Notice that in the natural numbers, you don't have any numbers like 2.6 or 97.3 or 4/7. Okay, so it's just the simplest sorts of numbers, the numbers that you learned about first when you were in kindergarten and you just started counting things, 1, 2, 3, and so forth. Now, the next type of numbers that we're going to learn about are whole numbers. And the whole numbers are just as easy, except we start with 0, and then we keep adding 1 to get the rest of them. So 0, 1, 2, 3, 4, 5, 6, 7, and so on. Again, for the whole numbers, we don't have anything like 7.2. We don't have anything like 1/3. Okay, it's just 0, 1, 2, 3, and so forth. Now, let's talk about integers. The integers are the numbers going to the right of 0 and to the left of 0 and including 0, except again, no decimals, no fractions like 2/3 or 4/9 or anything like that. So we have all the whole numbers here, 0, 1, 2, 3, 4, 5, and so on. But then we also go to the left of 0, -1, -2, -3, -4, and so forth. And now what about the rational numbers? Okay, so here we have to state a definition. A rational number is any number which can be written as the fraction of 2 integers. So let's pause there. What if I were to ask myself, is 4 a rational number? Well, to answer that, I would need to know if it can be written as the fraction of 2 integers. Well, 4 can be written, if we really wanted to, as 4/1. So if I wanted to, I could write 4 as the fraction of 2 integers, because 4 is an integer, right? Here it is, and 1 is also an integer. So I can write the number 4 as the fraction of 2 integers, and therefore 4 is a rational number. In fact, every single integer is a rational number. Okay, every single integer is also a rational number. And I'm going to talk a little bit more about that in a second. But let's continue with this here. So that's the definition of a rational number. Any number which can be written as the fraction of 2 integers. And that includes when I say NWI here, I mean that includes all of the natural numbers. So all of the natural numbers are also rational numbers. All of the whole numbers are also rational numbers. And all of the integers are also rational numbers. All of them, if we wanted to, we could just put them over 1, which would be expressing them as the fraction of 2 integers. Now, rational numbers also include terminating and repeating decimals. Now, actually, this is not in addition to that definition. Terminating and repeating decimals are included in this definition over here. What do I mean by that? So, what if I wanted to know if the number, let's say, I'll write it over here. What about the number 2/5? Is this number a rational number? Well, the answer is yes, it is, because we can write it, and I did write it, as the fraction of 2 integers. 2 is an integer, and 5 is an integer. So this fraction is the fraction of 2 integers, and therefore by this definition here, it is classified as a rational number. But notice something else. If I take 2 and I divide it by 5 to express it as a decimal, what happens there? 2 divided by 5, I get 0.4. Okay? So 0.4 is a terminating decimal. Terminating just means it ends. It doesn't go on and on forever. Okay? It ends right over here. That's the end of it. All right? And in fact, the converse of that statement is also true. If I have a number which is a terminating decimal, then it also must be a rational number. Okay? You will be able to write it as the fraction of 2 integers. Any number which is a terminating decimal can be written as the fraction of 2 integers, like 0.4 can be written as 2/5, and therefore it is a rational number. And the same thing goes for repeating decimals. So for example, what if I had the fraction 2/11? Well, I know that that is a rational number because I wrote it as the fraction of 2 integers. 2 is an integer and 11 is an integer. Now, if I divide 2 by 11, I get 0.18181818, and on and on and on. I get a repeating decimal. And in fact, any repeating decimal, I can go the other way, right? Here I started with a fraction and I turned it into a decimal, but I can go the other way and I can say this is true, that any repeating decimal can be written as the fraction of 2 integers. And therefore every repeating decimal would also be a rational number. So just like 0.18 repeating can be written as 2/11, every other repeating decimal and also every other terminating decimal can be written as the fraction of 2 integers, so they are rational numbers. Okay, now what about irrational numbers? Irrational numbers, as the name suggests, are not rational. So they cannot be written as a fraction of 2 integers. And also, if you were to write them as a decimal, they would not terminate, meaning they would not end. And they would also never repeat. So, for example, the number which we learned about pi, let me draw this in orange since I have the irrational numbers in orange. the number pi is equal to 3.1415926, and on and on and on. So it does not terminate, okay? It does not end. It goes on and on and on forever, but it also does not repeat. It's not 3.11111. It's not 3.14141414. It actually never repeats itself. So pi is not a rational number, it's irrational. You can write it as approximately 22 divided by 7. You'll get an answer here which is almost pi, but it's not exactly equal to pi. And in fact, you could try forever. You could try figuring out, you could ask yourself, you could try to write pi as, you could say that it's approximately 22 over 7, like I did over here. If you did 22 divided by 7, you get an answer which is almost pi, but you can see that you get the answer differs from the actual number for pi. And you could try to come up with numbers to put over here that would give you exactly pi, but you would never be able to do it. Okay, it's been proven pi cannot be written as the fraction of two integers. So you can pick two integers and you could get very, very close to pi, but you'll never get exactly pi. So it cannot be written as the fraction of two integers, and therefore it is not rational. It's irrational. Okay, now the last thing that I want to say before going on to this IXL exercise is that I want you to notice the boxes that I put around here. So you'll notice that I put this green box, not just around what I wrote here as the rational numbers, but around all of these. And the reason I did that is because actually everything here, the natural numbers, the whole numbers, the integers, are also rational numbers. So not only is -2 an integer, it's an integer and also a rational number. And you can make a similar statement over here. Notice that I have this pink box going around not just the integers, but also the whole numbers and the natural numbers. And the reason for that is because, for example, the number 3, it's a whole number, but it's not only a whole number, it's also an integer. Okay, so every whole number is also an integer and also a rational number. And I can make a similar statement for the natural numbers. Notice that the natural numbers 1, 2, 3, 4 are included in the whole numbers. And they're also included in the integers. And also they're included in the rational numbers because we could express them, if we wanted to, as the fraction of two integers. We could put all of these over 1 and write them as the fraction of two integers. We don't usually write them that way, but we could if we wanted to, so they fit the definition of rational numbers. So notice here that every natural number is also a whole number, also an integer, also a rational number. Every whole number is also an integer and also a rational number. Every integer is also a rational number. But I can't necessarily go the other way. So, for example, -4 is an integer, but it's not a whole number. And 0 is a whole number, but it's not a natural number. So I can go down here, and I can say that everything here is also this and this and this, but I can't necessarily go the other way. It does not always work to go the other way. All right, and finally, the irrational numbers here are completely separate. So if something is a natural number or whole number or integer or rational, then it is definitely not irrational. And if something is irrational, then it is definitely not a rational number, an integer, a whole number, a natural number. Okay, so these two boxes, this big green box which goes around all of these things, and this orange box are completely separate. So if a number is included in one of these categories, then it's definitely not an irrational number. And if it is an irrational number, then it is definitely not included in any of these categories. Okay, so how long was I talking there? Probably a long time, right? 15 minutes. Okay, so you had to listen to me for 15 minutes. Not the end of the world. So let's go ahead and do these IXL problems. They actually start out pretty simple. Is 10 a whole number? Well, the whole numbers are 0, 1, 2, 3, 4, 5, 6, 7. If I were to keep counting, then yeah, I would get to 10. So 10 is a whole number. So let's click yes there. Which of the following are whole numbers? Okay, again, let's remember the whole numbers are 0, 1, 2, 3, 4, 5, and so on. So 6 is a whole number, 0 is a whole number, 5 is a whole number, 4.7, no. We don't want any non-zero digits after the decimal point. This would not be a whole number. Which of the following is an integer? So remember, an integer is any number which can be written as the fraction of two integers. So 2 over 4, that's a fraction of two integers. 2 is an integer, and 4 is an integer. So this is good. 1 over 3 is also the fraction of two integers. 1 is an integer, and 3 is an integer. So this is good. 4, which, I'm sorry, I apologize. I thought this was asking me about rational numbers. I got confused for a second. Oh, I'm so sorry. I'm so sorry. Please ignore what I just said there. The integers are -1, -2, -3, -4, -5, and so on to the left, and then also 0, 1, 2, 3, 4, and so on to the right. So -4 is the only integer here. I apologize for what I said before. I was thinking of rational numbers. So these would be rational numbers, but they would not be integers. -4 is the only integer there. Okay, is 1 3/5 a whole number? No, the whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, etc. That would be a no. Which of the following is a natural number? Remember, the natural numbers are just 1, 2, 3, 4, 5, and so on. So 2 is a natural number. None of these are natural numbers. Which of the following are integers? Again, the integers are -1, -2, -3, -4, and so on. 0, 1, 2, 3, 4, 5, 6, 7, and so on. This would be an integer. If I were to count to the left far enough, eventually I would get to -67. 0 is an integer. In fact, I wrote it right over there. 20 is also an integer. If I were to continue this far enough to the right, eventually I would get to 20. Pi is not an integer. Pi is 3.1415, etc. The integers do not have 0.1 or 0.3. The integers don't have those non-zero digits after the decimal point. So we're not going to click on pi here. Going to hit submit. Is the square root of 98 a whole number? So this question is asking me, is there a whole number that when I multiply it with itself, I get 98? So what about 4 times 4? Is that 98? No. What about 5 times 5? Is that 98? No. And in fact, we can say, I know that 9 times 9 would be 81, and 10 times 10 would be 100. So I know that the square root of 98 must be somewhere between 9 and 10, but that means that it can't be a whole number. So 9 is a whole number, 10 is a whole number. There are numbers between 9 and 10, but they're decimals, right? They're not whole numbers. And you could go to your calculator also to do this one. So I'll click 98 here and then hit square root, and it's going to give me a number between 9 and 10. It gives me 9.899, etc. That is not a whole number, so we're going to click on no for that one. Which of the following... Whoa, I did not want to do that. I just wanted to erase this. Okay. Which of the following is an irrational number? So remember, the rational numbers include all of the integers, the whole numbers, the natural numbers. So in other words, if a number is a natural number or a whole number or an integer, then it is also a rational number. So 55 is, let's just say, an integer. It's also a whole number and a natural number. 55 is an integer, so it's also a rational number. 43 is an Oh, again, I did it again. I'm so sorry. This is asking me for which one is an irrational number. Okay, so anyway, 55, 43, and 52, these would all be rational numbers. Okay? And I know that very easily because they're integers, and anything that is an integer is also a rational number. So these numbers are rational numbers, which means that they are not irrational. Now, what about the square root of 78? The square root of 78 would be irrational. If you look at it in the calculator, here's 78, and we'll take the square root, and notice what you get here. Excuse me, you get a decimal answer. Now, if I'm thinking of rational numbers, decimal answers are actually okay as long as they are terminating, meaning they end at some point, or they repeat. So even if they go on forever, that's also okay, but they have to repeat themselves, like 1, 2, 1, 2, 1, 2, etc. Okay? This number over here, well, it's only terminating here because the calculator only has so many places, right? Eventually, the calculator is just going to have to cut it off at some point. But yeah, you can imagine this going on and on and on forever. And it would, in fact, go on and on and on forever. And it would not repeat itself. So this would be an irrational number. Okay, we would not be able to express it as the fraction of two integers. Is 76.187 a rational number? Okay, so any number which can be written as the fraction of two integers is a rational number. Let me get back to that definition in a minute, and I'll show you how that definition does, in fact, fit this number. But let's answer this question in an easier way, because I know that if a number is a terminating or repeating decimal, then it is a rational number. This number over here, 76.187, it terminates. It ends. After I get to this 7 over here, that's it. The number is over. So it is a terminating decimal. It doesn't go on forever. And therefore, I know that it must be rational by definition. Now, that's an easy way to check that if something is rational, if it terminates or repeats. But again, the technical definition of a rational number is a number that can be written as the fraction of two integers. So to see that this number does fit that definition, we could just write it this way. We could say that this number is equal to 76,187 over 100. Over 1,000. How do I know that? Because I know that if I were to take this number and divide it by 1,000, all I would have to do is take the decimal point and move it 3 spaces to the left, and then I would get this number back. So I can, if I wanted to, I can write this number as the fraction of two integers. This is an integer. This is also an integer. Okay, and therefore it fits the definition of what a rational number is. Okay, so it fits that definition, but again, an easy way to check is just to see that it is a terminating or repeating decimal. In this case, it is a terminating decimal because it ends right after the 7, or at the 7. Okay, so we're going to click on yes, it is a rational number for that one. Which of the following is an integer? Okay, so let's remind ourselves what the integers are. There are these nice numbers over here, right? We don't have to worry about decimals or anything messy. So it's just 0, 1, 2, 3, 4, 5, 6, 7, etc. moving to the right. And also -1, -2, -3, -4, etc. moving to the left. Okay, so 39 would be an integer. This would not, pi would not, and this also would not. Okay, this number is a repeating decimal. 8, I get 888 here after the decimal point. So this number would be a rational number because it's a repeating decimal. So that's an easy way that I can check that. 43 over 98 would also be a rational number because it's the fraction of two integers. This one I could also express as the fraction of two integers, but I'm not going to get into that right now. Pi would not be rational. Pi would be irrational. So we talked about that. But okay, we don't actually have to know that. All this question is asking for is which number is an integer, and 39 is the only integer here. So we'll click on that and then click submit. Which of the following are integers? Okay, remember what the integers are, and in fact all of these would be integers. We don't have any messy decimals or fractions to worry about. Okay, so these are all integers here. Which of the following are natural numbers? Okay, so the natural numbers are just the numbers that you learned about first when you were in kindergarten. These are the first numbers that you learned about: 1, 2, 3, 4. You didn't know about decimals yet. You didn't know about fractions yet. So which of these are natural numbers? 27 is, 21 is, this one is not, this one is not. Now you have to be careful. Just because we're taking the square root of a number, it doesn't necessarily mean that it's not a natural number. So for example, what if I wanted to take the square root of 81? Well, the square root of 81 is just 9, because 9 times 9 is 81. So a number can be written in this form with a square root here and still be a natural number, right? But the square root of 89 is not a natural number, and you can check that in the calculator. Oh, again, I did that. Didn't want to do that. You can check that here. The square root of 89 gives us this very messy decimal here. Clearly not a nice natural number. So these are the only two natural numbers, and we'll click Submit there. Which of the following is an integer? So for the integers, 15 would be an integer. Not this, not this, not this. So let's hit Submit there. Is 1 and 11 over 23 an integer? Again, we don't want to see fractions like this for integers. The only exception, there is sort of a trick that IXL could do, but I don't think they do it. So what if, for example, I wanted to write 2? What about this? Is this an integer, 2 over 1? 2 over 1 is actually an integer because it's just 2. It has the same value as 2. So that's an example of a twist that IXL could give you. It could ask you a question like, is 2 over 1 an integer? And you think to yourself, no, it's not an integer, but actually it is, because 2 divided by 1 is just 2. But you're lucky, because I don't think that the makers of IXL are going to trick you that way in this exercise. So basically, if you see a fraction here, it's not going to be an integer. So we're going to click on No for that one. Alrighty, which of the following describe pi? Select all that apply. All right, well, pi is simply an irrational number. Remember, if something is irrational, then it is none of these. It is not rational, it's not an integer, it's not a whole number, it's not a natural number. And conversely, if something is a natural number, a whole number, an integer, or a rational number, then it's not an irrational number. It's either one or the other. It's either irrational or it's rational. And rational includes all of these also. So pi is an irrational number only. It is not any of these other categories. Which of the following describe 93? Select all that apply. 93 is let's start from the beginning with the natural number. So 93 is a natural number. And in fact, if I know that something is a natural number, then it's also a whole number, because all of the natural numbers are included in the whole numbers. So 93 is also a whole number. And the same thing goes for integers. If something is a natural number, or a whole number, then it's also an integer, because again, all of the natural numbers and whole numbers are included in the integers. So if it's this, then it must also be this. Oh, but they don't give me integers here. So anyway, but I could make the same statement for the rational numbers. If something is a natural number, then it's also rational. Same thing for whole numbers. If something is a whole number, it's also rational. If something is an integer, it's also rational. Okay, so we're going to click on rational, but we're not going to click on irrational. If it had integer, then we could also click on integer, but it doesn't. So that's it, and we're just going to hit Submit over here. Which of the following describe pi? Didn't I just do this? It's an irrational number. Which of the following describe the square root of 73? Well, the square root of 73 is also going to be irrational. So I get this messy decimal here, and even though the calculator only goes up to a certain place, I can tell you that if the calculator could go on forever, then this number would go on forever and it would never repeat. So we're going to click on irrational here. Remember, if a decimal terminates or repeats, then it's rational. If not, then it's irrational. and terminates just means it ends. But it didn't end, so we're going to click on irrational. Which of the following describes 0? 0 is an integer. 0 is a whole number. 0 is a rational number. Remember, if anything is in one of these categories, then it's also in the rational numbers. So the rational numbers include the natural numbers, the whole numbers, the integers. 0 is not irrational. It is rational. So we're going to click on that and these also, and then we're going to click submit. Okay, I'm up to the challenge zone. So this is a pretty long, actually my other video went longer than this. I thought this one would go longer. I guess after that explanation in the beginning, it's not too bad, right? At least for me, you might be sitting there thinking, oh my gosh, when is he going to stop talking? But we're almost done. Which of the following describe the number 13? The 13, well, maybe if they had unlucky here. So for a long time, people believed that 13 was an unlucky number. I don't know why that is. So some people who are still superstitious think that 13 is an unlucky number, but unlucky is not an option for this exercise. So let's look at these other options. 13 is a natural number. 1, 2, 3, 4, 5. If we continue counting, eventually we'll get to 13. It is also an integer. Remember, if something is a natural number, then it's also an integer, because the integers include all those natural numbers there also. It is rational. It is not irrational. So we're going to click submit there. Which of the following again, this is the third time it asked me this. It's irrational. Getting tired of telling you that. Remember the next time I tell you that pi is irrational so you don't ask me again. Okay. Which of the following describe 12? Select all that apply. 12 is a natural number. It's a whole number. It's an integer. It's not irrational. So 12 can be found in all of these. And I could also say that it's a rational number, but it's not irrational. Square root of 82 is going to be irrational. Okay, 82, you can just do it in the calculator there, and you can see you get something incredibly messy. It would not terminate, and it also does not repeat. Square root of 68, also going to be irrational. 76 over 43, well, it's not a whole number. No, the whole numbers are these nice 0, 1, 2, 3, 4, 5, etc. So it's not a whole number. It's not an integer. Integers are also pretty nice. They just include the negative numbers also. Is it rational or is it irrational? Well, remember, a rational number can be written as the fraction of two integers. So here we have a fraction, and 76 is an integer, and 43 is also an integer. If I look at them separately, then 76 is an integer, and 43 is also an integer. So this fraction is the fraction of two integers, and therefore it is rational. So be careful there. 76 over 43 is not an integer, but the numerator by itself is an integer, and the denominator by itself is an integer. And any number that can be written as the fraction of two integers is by definition a rational number. So we're going to click on that, but we're not going to click on a whole number. We're not going to click on integer. And obviously, if something is a rational number, it's not irrational, because irrational just means not rational. So if something is rational, then it can't be not rational. So we're just going to click on rational, and we're going to click submit. And which of the following describe 38? That would be natural, whole number, rational, but not irrational. Which of the following describe 46? There's another very nice number for us. That would be a natural number. It would be an integer. It would be a rational number, but it would not be irrational. Which of the following describe negative 76? Okay, so it's a negative. Now, the whole numbers do not include the negatives. So if something is negative, then it is not a whole number. Same thing goes for the natural numbers. If something is a natural number, then it is not a... Sorry, if something is a negative number, then it is not rational. Again, sorry. If something is a negative number, then it is not natural. In fact, the only difference between the natural numbers and the whole numbers is the number 0. That's the only thing that separates them. Everything else about them is the same. So anyway, it's negative here, which means it's not natural. It is not a whole number, but it is still a rational number. It still can be written as the fraction of two integers. So for example, I could write it as simply negative 76 over 1, right? Because negative 76 is equal to negative 76 over 1. So I could write this number as the fraction of two integers. This by itself is an integer, and also this by itself is an integer. So it is rational, and that's it. It's not rational. It's got to be either one of the or the other. If it's rational, it can't be irrational. So we're going to click on submit there. And that is it. Dynamite. Okay, so we are done there. I hope that was helpful. Please, I did it again, but this time it's okay. Please reach out if you have any questions, and have a great day.